In this video, we're going to be taking a look at point-slope form. So we've been working with slope-intercept form of an equation of a line, and when we have slope-intercept form, we can tell the slope and we can point out the y-intercept for the equation of a line. In point-slope form, we can identify a point that isn't necessarily the y-intercept, but we can still identify the slope of the line. So we'll have some point x1, y1, and we'll have the slope m. In this form, it's written as y minus y1 equals m times x minus x1. Now if I wanted to get m by itself, all I would have to do is divide both sides by x minus x1. And I'm doing this just to show you where we get this form from. X minus x1. Let me use a different color here quickly. So I'm going to be dividing both sides by x minus x1 to get m by itself. So the x minus x1 will cancel, and we're left with y minus y1 over x minus x1 equals m. Hopefully this looks familiar to you because we get the point-slope form from the equation for slope. Slope is y2 minus y1 over x2 minus x1. Well, in point-slope form, we're only working with one point, so that's why we just have y and x instead of y2 and x2. So y minus y1 equals m times x minus x1 is our point-slope form. So our line is passing through the point x1, y1, and has the slope m. So for example, in the equation y minus 3 equals 1/2 times x minus 2, we know that the slope is 1/2 because that's m, and that a point on the line is going to be 2, 3 because the 2 is x1 and the 3 is y1. So if we take a look at how we can use this, in this example we have write an equation in point-slope form of the line that passes through the point 1, 6. So 1 is my x1, 6 is my y1, and has a slope, so that's m of negative 1/2. So if we remind ourselves, point-slope form is y minus y1 equals m times x minus x1. We know x1, we know y1, and we know m. So all we have to do is substitute for those three values. So y minus y1 is 6 equals negative 1/2 times x minus 1. And we have our equation in point-slope form. And that's all we're going to ask you to do in your assignment, is to write the equation in point-slope form. And we can do this from a graph as well. So we always need our slope. So the first thing we're going to do is calculate our slope. And from a graph, we can do that by counting the rise over the run. And I, as you've noticed, like to go from my left point to my right point. So I'm going to see how far up I'm moving and how far over I'm moving. And again, I'm going to count spaces. 1, 2, 3, 4, 5, 6 spaces up and 3 spaces to the right. And because I went up and to the right, both of those are positive directions. So I'm going to say a positive 6 over a positive 3. And I'm going to simplify my slope. 6 over 3 simplifies to 2. The next thing I'm going to do, I'm given 2 points on this line. I'm going to pick one of them and write my equation in point-slope form. Because I want you to see what happens when we have a point that has negative values, I'm going to choose the -2, -6. I'm still going to start with remembering that my point-slope form is y minus y1 equals m times x minus x1, and I'm going to substitute my values. So my -2 is my x1, my -6 is my y1. So I'm going to have y minus -6. So the minus is part of the form. My y1 is a -6 equals, my slope is 2 times x minus, my x1 is a -2. Again, the form has a minus in it, and the x1 value is a -2. Now it doesn't look very clean, very neat to have a subtract negative. So when we have a subtract negative, we can write this as y plus 6 equals 2 times x plus 2. I can do this same thing with the other point. I just wanted to show you what happens when you use a point that has negative values in it. And if we don't have a graph, if we're just given 2 points, we can find the slope. Now, I could just use the slope formula, y2 minus y1 over x2 minus x1. So that would be 10 subtract 4 over 3 subtract 1 is 6 over 2, which simplifies to 3. And if you have difficulty remembering the slope formula, but you can find the slope fairly easily using a table, convert those points to a table. So we have x is 1, y is 4, x is 3, y is 10. So my y increases by 6. My x increases by 2, so my slope, my change in y over my change in x is 6 over 2, which is 3. So you have 2 different ways to utilize to find your slope. And then again, pick a point. I'm going to go ahead and pick the first point. Remind myself that point-slope form is y minus y1 equals m times x minus x1, and substitute my values. So y minus y1 is 4 equals, my slope is 3 times x minus my x1 is 1. I don't have any subtract negative, so there isn't anything to clean up. And that's my equation in point-slope form. Oops, my directions don't say that. My directions should have said point-slope form. Next unit, we'll show you how to take this to slope-intercept form. And how does this work in an application? Let's take a look here at this taxi problem. To ride in a best-in-town taxi, you pay a start fee and a mileage fee. The table shows the total cost of a taxi ride for different distances. Can the situation be modeled by a linear equation? Explain. Well, to be modeled by a linear equation, we want that change in y over the change in x to be consistent. So distance is going to be our x, cost is going to be our y. So from 4 to 8 is 4, 13 to 23 is 10, 8 to 10 is 2, 23 to 28 is 5, 10 to 12 is 2, 28 to 33 is 5, Now if I look at my change in y over my change in x, I see 5 over 2, 5 over 2, and 10 over 4. To check to see if it's linear, I need to see if that 10 over 4 simplifies to 5 over 2. So I have my change in y was 10, my change in x was 4. I can divide both of them by 2. So my fraction simplifies to 5 over 2. And if I look at my remaining rates of change, 5 over 2, 5 over 2. So yes, this can be modeled by a linear equation because the rate of change is consistent at 5 over 2. So we have our slope, that's our rate of change. And now we're going to write a linear model. We're going to write that linear model in point-slope form. So we can pick any pair of points in this table. I'm going to go ahead and just use the smallest pair. So I'm going to use the point 413. And remind myself that point-slope form is y minus y1 equals m times x minus x1. So we have y minus 13 equals, and since this is a word problem, I'm going to convert that 5/2 to 2.5. So our slope is 2.5, and what that's representing is dollars per mile times x minus 4. So that's our equation in point-slope form. How much would it cost to ride in the taxi if you need to travel 7.6 miles? Well, as we pointed out earlier, miles, distance, is the value is x. So we're going to take our point-slope form, the y minus 13 equals 2.5 times x minus 4, and we're going to replace x with 7.6. So y minus 13 equals 2.5 times 7.6 minus 4. And again, I'm replacing the x with 7.6 because the x represents distance traveled. And now we solve for y. So y minus 13 equals 2.5 times 3.6 y minus 13 equals, let me grab my calculator, 2.5 times 3.6 is 9. Now something we haven't done a whole lot of, but hopefully you can remember, if you want to get the y by itself, you want to undo the minus 13. You want to do the inverse of subtract 13, which is add 13. And if you do it to one side, you need to do it to the other side. So we're going to add 13 to the other side of the equation. So our answer is going to be y equals $22. And that's how we can use point slope form to model